My name is Zheng Dong from Indiana University, and this is a joint work with Professor Jing Camp. Today I'll present a new approach to design security systems using peer production and crowdsourcing techniques within small-scale, self-organized communities. Peer production has been very effective, while crowdsourcing is a popular and also distinct approach for firms to outsource the production of goods and services. The crowdsourcing target could be an undefined and also potentially untrustworthy set of entities. Back to security. Although several defensive options have been made available to end users, the percentage of the patch systems is still not enough for resilience. Consider the following example. Everybody would benefit with their no spam. However, even if one individual makes sure that her own machine is not part of the botnet, she will still not see a decrease in the spam email received. People thus do not feel obligated or do not have enough incentive to invest the time, accept the possibility of lack of compatibility when applying patches, or to protect some indeterminate strangers from a possible increase in spam. The previous research has also shown the value of the incentive-aligned design. In this position paper, we propose that peer production and crowdsourcing designs could be incorporated in the security system design. We introduce the following 7 guidelines. First of all, system design in any case must start with a clear security goal that addresses one or more security threats. For instance, we can imagine that the end users and internet service providers would take diverse countermeasures to stop the spam emails. Targeting different combinations of actors and also threats will involve distinct assumptions and hypotheses. Second, the system needs to have a clear definition of the desired user behavior. For example, it has been documented that the prompt system patching has become one of the most effective ways to reduce the number of machines that are vulnerable to threats. 3. A reputation component needs to be built to indicate the compliance with the desired user behavior. Reputation could also be used in communicating the importance of timely recovery. 4. Self-organization is a crucial component to peer production. This organizational structure should not only lower the cost of system maintenance, but also enable security to be achieved more efficiently, while crowdsourcing is normally organized by a firm. 5. From an economic perspective, determining the correct size of community is necessary to maximize the social welfare. Intuitively, an individual would have a higher incentive if she knows the rest of the community members. Further, while a larger community may mean more potential contributors, it may also lead to a higher probability of including a malicious user. And 6. Each community member should be able to distinguish a reputable person from another individual with lower reputation. Intuitively, this visibility would potentially incentivize the community members to build their reputation by contributing to the communities. 7. Make detection and mitigation actions clear and simple so that specific solutions are easy to implement for each undesirable user behavior. So for example, once a vulnerable machine is discovered through a system scan, make it simple to receive and apply only the correct patch. As an instantiation of a security system design, we introduce a scenario of mitigating the insider threats. We chose this scenario because it is one of the most difficult problems in security and also requires cooperation from all employees. In FC09, Liu et al. Proposed a budget-based access control framework to mitigate the insider threats. The insiders refer to any employees who have been granted the data access privileges to some sensitive information, for example, financial data or human resources data. Well, it's very difficult to prevent these individuals from abusing the data access privileges, since a computer application could not automatically distinguish an ordinary data access and an unnecessary or even threatening access. With the risk budget, appropriate incentives are provided to each individual with the data access privileges so that individual incentives align with the organizational interests. At the beginning of the risk budget allocation period, the company would calculate the overall risk budget and then allocate it to all employees for whom the access to sensitive information are absolutely needed. Each data access action is marked with a price in risk points and results in a reduction of risk points from their individual risk budget. Employees with zero or even negative risk budget would be subject to review of their data access or to some form of punishment. Liu et al. Identified the following 4 types of end users. First of all, inadvertent individuals who are risk-averse nonetheless perform some potentially risky behaviors during their normal work. Second, the careless insiders who perform some risky actions but not intentionally. Third, malicious insiders who perform some risky actions intentionally and may affect other community members. And at last, malicious outsiders who have subverted maybe one or more machines of the community to obtain the insider status and privileges. So in our work, we propose that the mechanism of the risk budget could be migrated to the crowdsourcing design to further improve its efficacy. The new design is based on a set of small self-organized communities. Employees may be initially assigned to a group, or they may choose to join a group by themselves. One possible approach would be assigning the homogeneous individuals to the same group. The advantage of this method is that each group member would roughly utilize the same percentage of the risk budget in the group. While the disadvantage of this approach is that since the homogeneous individuals are not necessarily good friends, nor can they persuade or incent others, so the group members may have lower incentives to contribute to the security in the community. Any potential risky actions from the security perspective may be identified as threats, especially for those affecting the community members. Generally, each individual with the same tasks will be allocated the same amount of risk budget at the beginning of the risk budget allocation period. Exhaustion of one's risk budget may lead to warnings, damage to one's reputation, or even exclusion from the community. So imagine that if a careless insider or a malicious insider has been invited or included in a group in which all other individuals are well-meaning and also risk-averse, then there is a strong incentive to exclude that person or police his or her potentially risky behavior. By police, we refer to enforcing social norms, for example, through the threat of exclusion from the community or reporting the malicious behaviors to the firm. Another effort in our design is to enhance the overall level of security is to make individual and group reputations visible to a wider audience. Essentially, we argue that the total risk budget balance and the balance of other group members' risk budget should be made visible. For a strong framework, groups could share the aggregates as well as the individual risk budget. So if Alice, Bob, and Carol are in a group, when Alice goes over, she begins to exhaust the points available to Bob and Carol. This would be appropriate when Bob and Carol have some persuasive power of influence over Alice. Another challenge of this community-based design is to identify a potential malicious individual from another community while preserving the individual privacy. This is solvable with sharing the risk point aggregates between groups. This approach requires that each group publishes the amount of budget that has been utilized to other groups. So imagine the situation when Eve is from a malicious community, shown on the left, And benign network members, shown on the right, would know immediately that Eve is suspicious, since they know that the members on the group left have a lower point balance on average. We argue that our proposed framework could significantly mitigate the insider threat